Now let's discuss the mass flow in a tube. In a tube, when a liquid is flowing, let's say, because of the viscosity of the liquid, there is something that we call as velocity profile. Towards the edges of the tube, the velocity of the flow is very low. Towards the center, velocity is higher. So how do we calculate mass flow rate in such a system? We are going to use integration. What we are going to do is, we are going to consider a small cross-sectional area of this mass flow. So let's say that small cross-sectional area is dAc, and the mass flow through this small area is going to be density into the velocity of the mass flow rate into the area. And if we integrate this across the entire surface area, we are going to get the mass flow rate through this tube. To get the volumetric flow rate, we can simply integrate VA dAc throughout the entire surface of the cross-section of this tube. However, this is a bit inconvenient. We are not really interested on the velocity profile. What we are interested in is total mass flow through the system. So we don't have to do this all the time. What we are going to do is, we are going to define an average velocity. So the average velocity is the velocity that can give an equivalent mass flow rate if the velocity was constant throughout the cross-sectional area of the flow. So how we calculate average velocity is, V average into cross-sectional area is equal to volumetric flow rate. So using V average value, we can calculate m dot mass flow rate through the tube. So in this course, when you are told that the velocity of a liquid that is flowing through a tube is this much, that means velocity average.